Good morning, guys. I hope you're doing well. So, um, I'm still looking at the results from your tests, but so far it looks good because the class average is about 20.5 out of 25. So that's good. And yeah, you'll see your final grades today on your Google Classroom and also on your ThinkWave. Today we'll start Unit 3, and Unit 3 is going to be very short because you guys will be doing this Unit 3 test next week on Thursday. So yeah, just keep that in mind. This test is going to be next week on Thursday or at most Friday. We'll see how fast we can do some of these things. So this unit is called Simple Algebraic Fractions, and as you hear it, it's very simple fractions, just normal fractions but with letters in them. Alright, so at the end of this unit, these are some things that we're trying to look at, or these are our objectives for this unit. Number one, you should be able to express an algebraic fraction, and when you see these words, please don't get scared. Algebraic fraction simply means a fraction that has a letter. So like a over 2, that's an algebraic fraction. X over 4, that's an algebraic fraction. 3 over y, so just a fraction that has a letter. And what we'll be doing is try to express them in their simplest form. We're going to learn how to perform the 4 operations, addition, subtraction, division, and multiplication on these fractions, right? So just imagine you had things like that there. So much fun. You guys are going to see how to do this. We will change the subject of a formula, including those involving square root. So this is just an example. If you have x is equal to y plus 2, you can be able to write this as y is equal to x minus 2, right? If you don't know where this is coming from, don't worry. When we get to this section, we'll talk about that in detail. And finally, we'll try to find the value of an unknown quantity in a given formula. So like in this formula here, if y is equal to x minus 2, and you're told that x is equal to 5, then you're finding the value of an unknown quantity, which is y, and that is 3. So this is basically this whole unit. As you can see, there's very few things to do, and the unit is going to be short. But let's first start by looking at what each of us remembers. If you get this right, you can get a cookie. So you can tell me your answers. Pause the video now, tell me your answers in the comments or in the private comments, and get your cookie. You'll get those cookies last week on Thursday. So yeah. The values of these fractions in their simplest form. Let's start with this one. I hope you can see that we are dividing by 0, right? And division by 0, I hope you remember, is undefined, right? Undefined. 0 people cannot share 2 mangoes, right? Because that's an undefined quantity. You do not know what's happening. On the other hand, 0 divided by 2, that is defined, and that's 0. 0 divided by anything is 0, but anything divided by 0 is undefined. So here, unlike this case, here we said that 0 people cannot share 2 mangoes because, you know, there's 0 people, so you don't know what anyone is getting. But here, 2 people can share 0 mangoes. Everyone will get nothing, right? These are 2 people. They can share 0 mangoes, and everyone gets nothing. Everyone gets 0 because there's 0 mangoes to share. A fraction like this, if we want to simplify it, you guys remember, I can divide by 6, I can divide by 2. You can go as slow as you want, but you can just quickly divide by 12 to get to 1 out of 2. Or you can say, let me first divide by 2, then I'll get 6 out of 12. Then I'll divide by 2 again, then I'll get 3 out of 6. Then I'll finally divide by 3 and get 1 out of 2. Or you can just directly say I'm dividing by 12 and I'm dividing by 12 and I get 1 out of 2, which is the same answer. Now there's another one, obviously. This one down here. Huge fraction that looks so scary, but I promise you that it's possible to simplify this fraction. And that is going to be the point of this lesson, to see how we can simplify algebraic fractions like this. If you can already simplify this fraction, because what you're going to do really is going to factorize this, and you would factorize this last week, and you're also going to factorize this by grouping. So if you can do that, you can go ahead and do it. But this is going to be the emphasis of this lesson, to try and figure out how we can simplify fractions like this. And I know that naturally when you look at something like this first time, you get scared, right? It's natural, you get scared because there's so many letters and so many numbers put together. But just think of it as a puzzle. Just think of it as a puzzle that you're going to solve. Just think of it as a level in a video game. And you guys are absolutely capable of figuring out this puzzle and solving it. Because what you have in the top is a quadratic expression which you can factorize, and what you have in the bottom is also factors, which, you know, there's so many things that have common factors which you can factorize. So like I said, in this lesson we'll be seeing how to simplify expressions like this. So let's move on. Oh, there's more. This, I hope you guys remember how to get LCM and how to use your LCM to add fractions, but you don't even need to do that here because these fractions have the same denominator, and since they have the same denominator, I can just add the numerator. So I'll just add the numerator, which is 1 plus 4, which is 4 divided by 4, which is equal to 1. Now, all of the rules of dealing with fractions that you know from 6th grade, from 7th grade, we're going to employ those rules again here. So nothing is changing. The only thing that's changing is that sometimes you have letters, which is okay. Everyone likes letters. Alright, so this one, 4a divided by 8, I can see that 4 and 8 have a common factor which I can divide or can reduce. So if I divide this by 4, I get 1. If I divide this by 4, I get 2. So this whole fraction reduces to 1 out of 2 times a, which you can just write as a divided by 2. And then look at this one here. If you look at the numerator, 4 is common, so I can take out 4 and I remain with a plus 1, right? And in the denominator I have 8. And then just like the previous one, the 4 and the 8 can be reduced because I can divide by 4. I can divide by 4 to get 1, and I can divide by 4 and 8 to get 2. So then my final answer will be a plus 1 divided by 2. And then finally, I have 3m divided by 3 divided by 4. I am pretty sure that Miss Caitlin taught you how to use the KFC method last year, right? KFC, which says keep, flip, change. Keep the first fraction, flip the second fraction, change the sign, right? Or basically take the reciprocal. So I'll keep the first fraction, which is 3m over 1. I will change the second fraction instead of, I'll flip the second fraction, which is 4 divided by 3, and then I'll change the sign to multiplication. So then I'll end up getting 3m times 4 divided by 3, but I hope you can see that this 3 can cancel with that 3, and you get 4m divided by 1, and your final answer is just 4m. So what I've done in each of these questions is I have simplified algebraic fractions, right? I've simplified fractions. I've written them in their simplest form, and honestly that this is the gist of what we're going to be doing in this lesson. Alright, so let's first look at Alexa's dilemma. I hope you guys all know Alexa. If anyone does not know Alexa, she's going to send you an email introducing herself and telling you all the things she likes, so you know what to get her for her birthday. So Alexa's mom sent her to a drug shop or drugstore to get specific quantities of the following these prescriptions: 0.4 kilograms of amoxicillin, 0.2 kilograms of glucophage, I don't know what that is, 1.5 kilograms of hydrochlorothiazide, wow, 0.5 kilograms of zithromax, and 0.25 kilograms of levothyroxine. Very complicated things, but being a smart person, she creates some kind of way or format to remember these names. So to memorize these strange names, they surely are strange, she uses the first letter of the drugs to make a note, and then she writes them as the following: 4 out of 10A, which makes sense because 0.4 is the same as 4 out of 10, smart Alexa, and A stands for amoxicillin. Alright, so then she says 0.2G. Hope you can see 0.2 is the same as 2 out of 10, and G stands for glucophage. 1.5 is the same as 15 over 10, and that's H for hydrochloro, blah, 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 that one. And then 0.5 is the same as 5 out of 10, which stands for zithromax. And finally, 0.25 is the same as 25 out of 100, and the L stands for levothyroxine. So she has already simplified her work, because when you look at this, I know when you saw these names, you're like, what is going on? But I hope you can see how very simply you can simplify those names. You can simplify those expressions and write them in terms that are not so scary. So what they're asking us to do is to write these drugs in their simplest form, and I hope you can see 4 out of 10 I can reduce by 2 to get 2, and 10 divided by 2 is 5, so my answer there is 2 out of 5A, right? Here by 2 is 1, and by 2 is 5, so I'll have 1 out of 5 G. Here by 5 is 3, by 5 is 2, so I'll have 3 out of 2 H. And here by 5 is 1, and by 5 is 2, so I'll have 1 out of 2 Z. And finally here by 25 is 1, and by 25 is 4, so I'll have 1 out of 4 L. I have written those fractions in their simplest form. Question 2. If she bought 1/4 of everything, what amount of each drug did she actually buy? Right? If she bought 1/4 of everything, what amount of each drug did she actually buy? You guys can figure this one out. I'm going to let you figure it out. So she bought 1/4 of the first drug, right? She bought 1/4 of the second drug. She bought 1/4 of the third drug, 1/4 of the fourth drug, and 1/4 of the fifth drug. So all you have to do is substitute what the fractions for those drugs are. 2 out of 5, 1 out of 4, sorry, was it 1 out of 5? I don't remember the letter. G, 3 out of 2, H, 1 out of 2, and 1 out of 4. So this is 1 out of 2 and 1 out of 4. This is L, and the previous one was Z. So all you have to do here is really multiply these fractions, right? All you have to do is multiply. That's all you're trying to do here, right? And I trust that you guys are capable of doing this. I trust that. So yeah, you guys go ahead and do this. Or should I do it? I'll do it. If you can do it, pause the video or skip ahead, but I'll just go ahead and do it. So 1 out of 4 times 2 out of 5A. If you look at this, 2 reduces the 4, and then you end up with 1 times 1 is 1, and 2 times 5 is 10. So 1 out of 10A. And the second one, 1 out of 4 times 1 out of 5G, that's the same thing as 1 out of 20G. 1 out of 4, the third one, times 3 out of 2H is the same thing as 3 out of 8, because 4 times 2 is 8H. And this one, oh wait, I did that one. This one is 1 out of 4 times 1 out of 2, Z. That's the same thing as 1 out of 8, Z. Boom. And then finally, 1 out of 4 times 1 out of 4, L, is the same thing as 1 out of 16, L. So the last question, is Alexa a good daughter? I'll let you guys decide, because her mother asked her to get this much, but she only got 1/4 of everything. So you let me know, is she a good daughter? Alright, so this is something that I need you to write down, but I'm going to go through it and explain what's happening. Like I said earlier, if you see words, do not get scared. Words are just describing what's going on. If I have a number in the form P out of Q, this P can be anything. It could be 1 out of 3, right? It could be 4 out of 7. It could be anything. Where P and Q are integers and Q is not equal to 0, remember we cannot divide by 0 because division by 0 is undefined. That's why this is saying Q, this Q here in the denominator cannot be equal to 0. That number is called a fraction. For example, all of these are fractions. This is something you already know. Alright, in algebra, an algebraic expression of the form P divided by Q, where P and Q are expressions. So expressions just means like A, it could be the letter A, it could be the letter X, it could be X plus 1, it could be whatever. That's what an expression is. Involving addition, subtraction, and multiplication, and Q is not 0. Remember again, what I'm dividing by cannot be 0 because division by 0 is undefined. That's called an algebraic fraction. For example, each of these things here are an algebraic fraction. So basically, if you have a letter in a fraction, it automatically becomes an algebraic fraction. Alright, let's look at some examples, then I'll give you some homework on Google Classroom. So these algebraic fractions I'm going to first reduce the numbers because I want to write them in the simplest form. I'll first reduce the numbers, then I'll try to reduce the letters. Or I can even go the other way. If you look at this, A is common here and A is common here. So I can cross out the A. This is B, right? I have one B there and I have two B's here, right? So what I have is 12B divided by 15B times B because it's B squared. And I hope you can see clearly that I can cross out the top B with one of the bottom B's. So I'll end up with 12 divided by 15B, and 12 and 15 can be each reduced by 3. Yeah, by 3 to get 4 and by 3 to get 5. So my final answer is 4 divided by 5B. Let's look at part B. M is common in the top and bottom, so I can cross it out, right? I can reduce 6 by 2 to get 3, and I can reduce 10 by 2 to get 5. So what I have left in the top is 3n divided by 5. Finished. Let's look at this one. I hope you guys remember factorization. What's common is 3 is common, and I'll have 1 plus 2a. And then in the denominator, I hope you can see that 6 is common, and then I'll have 2 minus 3b, right? Now, of the things inside the brackets, I cannot reduce because, they're inside the brackets, and there's nothing common. But if you look at outside the bracket, 3 and 6 can be reduced. I can reduce 3 by 3 to get 1, and I can reduce 6 by 3 to get 2. So my final answer would be 1 into 1 plus 2a divided by 2 into 2 minus 3b. I don't even have to write this one, right? We don't have to write that one. Alright, let's go to D. D is this one here. The top is a quadratic expression, and I hope you guys remember how to factorize quadratic expressions. I have 1x squared and I have 24. I can just do the puzzle, and I need that puzzle to add somewhere, and then finally be equal to 10x, right? That's what's in the diamond over there. Factors of 1 are just 1 and 1, 1x and 1x. The factors of 24, I'm going to use 4 and 6 because I'll get 4x here and 6x there, and those two add up to give me 10x. So then I'll do my diagonals to get my factors, and at the end of the day my factors will be x plus 4 into x plus 6. So that's what I have in the numerator. This whole numerator simplifies to that, but in the denominator I also have another x plus 6, and I hope you guys can see that very conveniently the x plus 6 can cancel out. So this whole big thing that was so big and scary reduces to just a simple x plus 4, right? And finally, I'm also going to approach number 3 the same way I approached I'm going to approach 3 the same way I approached 2D. Doesn't even make sense. This numbering doesn't make sense. So if you look at 3, what I'm going to do is start with the numerator. The numerator is a quadratic expression. I need to factorize it. I have 2x squared, I have negative 15. And then I will add, and then I have that equaling to negative x, right? So the factors of 2x squared are just 2x and x. The factors of 15 that will combine to give me negative x. What factors are these? Can I use 1 and 15? No. Can I use 3 and 5? Let's see. If I use 3 and 5, but this has to be negative. I know that 2 times 3 is 6x, right? And x times 5 is 5. So if I'm adding these and I need to get negative x, that means the 6 has to be negative. That means the 3 has to be negative. And that's how I'll get negative x. So then I'll do my diagonals and get my factors as x minus 3. My factors will be 2x plus 5 and x minus 3. Now that's what's in the numerator. In the denominator, I still have something that is 9 minus x squared. But I hope that you guys remember that 9 minus x squared is actually the same thing as 3 squared minus x squared, because 9 is 3 squared. And when you look at this, I hope you remember that when you have a squared minus b squared, the difference of squares is the same thing as a minus b into a plus b. So that means that my 3 minus x squared can simplify into 3 minus x are 3 plus x. So that's what I'm going to write in the denominator here. I'm going to write this in the denominator, and I'll say, first write the numerator, and now I write the denominator, that is 3 minus x into 3 plus x. I hope you can see that 3 minus x and 3 minus x, let me write this again, 2x plus 5, x minus 3. 3 minus x can be written as x minus 3 with a negative on the outside, and then 3 plus x can be written as x plus 3. So that cancels with that, and then I'll end up with 2x plus 5 divided by x plus 3. Alright, so I'm going to post your homework on Classroom. Bye.